Right, hey y'all. I know I said that I was going to do a couple of more difficult problems from the homework assignment on page 487, 488. So that's what I'm going to do. So I have three problems that I'm going to do. They're all on page 488. If you have other problems you want me to do, can you just send me an email and I'll post them up here so you can look at them if you can't get to a place where you can work on them. With me. So I'm gonna start with number 59. Number 59 asks us to solve for theta. And it's got 2 sine squared of theta minus sine of theta minus 1 equals 0. Let me rewrite that. Okay, so when I was talking in the notes, this is just like a quadratic equation, right? In fact, if I wanted to rewrite this, but just say, hey, I'm going to make x equal the sine of theta, what I can write this as is 2x squared minus x minus 1 equals 0. So that just looks like a regular old quadratic equation, right? And we can solve it just like a regular old quadratic equation. Now, if you wanted to, you could do some factoring with this. You could use the X box method. I don't necessarily want to try to describe how to do that on here, so I'm going to use our old tried and true friend, the quadratic formula. Right? Bear with me. I know you're probably rolling your eyes and like, no, but the quadratic formula works. It works. Let's remember it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what x is equal to. So let's go. Let's just plug and chug. So let me go up here and just make a note. So this is my A value. My B value is going to be a -1, and then my C value is also going to be a -1. So let's go. So negative B is -1 plus or minus the square root of -1 squared minus 4 times 2 times -1. I'm going to extend that a little bit. All over 2a, which is 2 times 2. Now, again, if you know how to factor this, it's tricky to factor because we've got that, or I guess I should circle that guy right there. We've got an a value that's not 1. There is a way to do this. You can just guess and check. You can, like I said, use the little X box where you have a little box like that, and you're trying to figure you have a 2 up here and a 1 down here, and you're trying to figure out what those are. You can definitely do that. I'm using quadratic formula because I know it works, and I know I'm not going to mess something up. So let's keep on. So -1, that's going to be +1 plus or minus. So -1 squared is 1. -4 times 2 is 8 times -1 is -8. So it's +1 minus a -8. So it's just 9. Oh yeah. You can also just type all that in a calculator and get it, and that's going to be all over 4. Y'all, what's the square root of 9? Easy. Plus or minus 3 over 4. So at this point, we can split this into two things. And remember, we said this was x, but what I said up here, remember, was that x equals sine of theta. So I can say, all right, so sine of theta either equals 1 plus 3 over 4, or sine of theta equals 1 minus 3 over 4. So 1 plus 3 over 4 is 4 over 4, so that's just 1. 1 minus 3 is -2 over 4, so that would be -1/2. So now, from there, oh my golly, look, I've already used a whole page. I can just say, all right, so what's the inverse sine of 1? That's going to get me to theta. And then over here, I'm going to do the inverse sine of -1/2. That's going to get me to theta. So let's obviously draw, I'm just going to put both of these on one unit circle. So when is sine, so the sine is the y value, so when is sine equal to 1? That's going to be right up here at pi over 2. So I know here that pi over 2 is equal to theta. And then when is the sine value -1/2? Again, sine is the y value. So That's these two places, and I believe that is 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6 equal theta. And remember, y'all, when you have two separate answers, for your final answer, just put them all together in a solution set. So this is going to be pi over 2, comma, 7 pi over 6, comma, 11 pi over 6. Solution set, done, done, done. Yay, that's it. So whenever you see a quadratic situation, try factoring first. And if you can't factor, don't be afraid of using the quadratic formula. It's really nice, and it works. So, boom. Okay. The next one I was going to do was, a student asked me to do 67. So let's get on over to 67. This is a throwback, to unit 1. So 67 says cosine of theta equals negative sine of negative theta. So we need to get this down to one function, right? This is not going to work for us. Even if we could get it down to two functions, the fact that this is negative theta in there is just throwing my game off. So way back in unit 1, do you remember we talked about even and odd functions? So if we think about sine, the sine function looks like that. So is the sine even or odd? That is the sine, and it is in fact an odd function. So algebraically, the way that we know, I don't know if you remember this, the way that we know that a function is odd, we can figure it out, is if the negative input is equal to the negative output. So if I make the input negative, then the output is also negative. And if that works out algebraically, then I know that that's an odd function. So the thing is, what I can do, since I know this is an odd function for a fact, sine is an odd function, then what I can say is I can actually change this sine of negative theta to negative sine of theta. So there's a negative sign outside, that's that guy right there. And then I can say, oh, this is the same thing as negative sine of theta. Now, y'all, I'm gonna let you know on the test, I'm not gonna ask you to remember even and odd stuff way back from module 1 or from unit 1. But it's good to do this practice and to kind of keep that at the tippy top of your brain, because I don't want that to just slide down to the back and get filed away somewhere where you'll never think of it again. Okay, so back to this problem, cosine of theta, negative and a negative, that means that this is just going to be a positive sine of theta. And y'all, there is some stuff we could do to like super mathematically solve this, but let's just think on the unit circle, where is a place where the sine and the cosine are exactly the same? So the x value and the y value are exactly the same as each other. There are two places that happens. One is right here at pi over 4, because it's rad 2 over 2 comma rad 2 over 2. So pi over 4, and the other one is right back over here at 5 pi over 4, because it's negative rad 2 over 2 comma negative rad 2 over 2. So those are just the two places where the sine and cosine are exactly the same. So, if you get to a problem like this on the test and you're just like, hey, I know what that is just by looking at it, that's fine. Make sure you draw me that picture though. So I'm gonna say pi over 4, 5 pi over 4. That's my solution. Yay. Yay. Okay. I actually only have one more, and I had planned on showing you this, and then a student asked me also to show it. So it's number 69. The tangent of theta equals 2 times the sine of theta. And I'm sorry, the book doesn't put parentheses, or maybe the book does, and I'm being lazy. Okay, so y'all, dang, this looks difficult. Because I need to get down to just one trigonometric function, right? So let's think to myself, how can I get I don't want to divide by anything. I don't want to divide any functions out, right? So what I'm going to do is I'm actually going to change tangent to sine of theta over cosine of theta, right? So I'm using some secret, one of my secret strategies for identities, when I was proving identities, right? Now, when the sine over cosine is equal to 2 sine theta, so let's think about this. What I'm going to do, and like I said, this is tricky. These are tricky problems. I'm actually going to move the sine over to the other side by subtraction. I'm not going to divide because I don't want to cancel it out. Don't cancel it out. So I'm just going to move it over to the other side. So I'm going to say the sine of theta over cosine theta minus 2 sine of theta equals 0. Okay, ooh, 0 is promising because that means if I can get this into 2 separate factors, then I can split it up into 2 factors, and that's going to be really easy to solve. So y'all, is there anything in common with these 2 terms? So I have a term right here, sine over cosine, and then I have a term right here, a term right there, 2 sine. Do those have anything in common with each other? If you're telling me, Ms. Ray, they both have sine in them, yes, you are exactly correct. So what I'm going to do is I'm actually going to factor out the sine from both of them. So sine of theta times, so sine of theta times what right here would get me back to sine theta over cosine theta. That's just going to be 1 over cosine theta. So if I multiplied this times that, it would get me back to this up here. So I'm just, it's like reverse distribution, basically is what I'm doing. And then sine of theta times what would get me negative 2 sine of theta. That's just negative 2. And that equals 0. So shablam, just like that, I have 2 factors, 2 things being multiplied by each other that equals 0, which means I can split these apart and say, oh, okay, so either sine of theta equals 0 or 1 minus cosine of theta. Oops, not 1 minus, Lindsay Ray. 1 over cosine of theta minus 2 equals 0, right? Piece of cake. So now what I can do, let me draw a little unit circle for the sine of 0 right here. I can say, oh, when is the sine of theta equal to 0? That is the y value, right? So that's going to happen right here and right here. So that's at 0 and at pi. So I'm going to say, all right, so theta equals 0 and pi. Now over here, I've got a little bit more work to do. So let's start by moving the 2 to the other side. So 1 over cosine theta equals positive 2. Now, 1 over cosine theta is equal to secant, right? I unfortunately don't have all of the secant values memorized for the unit circle, but what I do know is I can use the law of reciprocals. It's not a law of reciprocals. I'm just making that up to say things. What I'm going to do, I'm just going to flip this side right here and just make it cosine over 1, right? So I'm just going to flip it upside down so that becomes cosine over 1, which is just cosine, right? If I flip that side, then I have to flip the other side over here. So this is 2 over 1. So I'm going to flip that, and it's going to become 1/2. Now, friends, you see where this is going. We totally know in the unit circle where cosine of theta is equal to 1/2. So let's draw our little unit circle over here. I'm just going to kind of squeeze it in the corner. Boop. I don't know why I'm acting like this is real paper that I need to not go on the other page, but that's fine. So cosine of theta is 1/2. Cosine is the y value. So, or sorry, the x value rather. So that's going to be right there, and then it's going to happen again, another positive 1/2 down there. So that is at pi over 3, and this is 5 pi over 3. That's not 3 at all. 5 pi over 3. Shazam-a-rama. So for this one, I'm going to say theta equals pi over 3 and 5 pi over 3. So remember, when I have 2 separate terms or expressions that I'm solving for, and I get answers for both of them, then at the end, I just need to push them all together in one giant solution set. I do prefer, if you can, putting them in order. So 0 is obviously the lowest, pi over 3 comes next, pi comes next after that, and then 5 pi over 3 comes after that. please don't distress yourself if you feel like you can't put them in order. You don't like, you're like, oh my God, I don't remember fractions. I can't, it's just too much. Just write one set and then write the next set. I'm not going to count off for that. I want you to practice that, because in mathematical circles, when you're writing answers in a set like this, in a solution set, you usually want it to be from smallest to largest. So that's why I want you to kind of just practice that. But if you get to the test and you're like, then don't worry, just relax. Okay, y'all, those are the only three that I looked at and saw. This first one with the factoring, the quadratic, there are a couple like that. There are a couple that feature an even and odd type situation. I think that was the only one like that, but I just thought it was super fun, so I wanted to show you. So remember, like I said, if there's others that you want to see, holler at me, let me know. And yeah, that's that. So y'all have fun. I will see you. Get out and enjoy the sunshine, because it's beautiful. Okay.